Okay, at this point, we can multiply complex numbers. We can divide, find the quotient of complex numbers. We can raise a complex number to the nth power. And now what we're going to do is we are going to find the nth root of a complex number. So this is our objective today. So here I want to find the sixth roots of negative 729. Now notice it says roots. The reason it says roots is because where does this come from? The sixth root of negative 729. It comes from the sixth root of negative 729. It comes from this polynomial. You have x to the sixth equals negative 729. So if I send that back over, I have this. Now, if you remember, the corollary to the fundamental theorem of algebra says any polynomial to the nth degree must have exactly n roots. So this sixth degree polynomial has to have 6 roots. So I can start factoring this. This is the sum of cubes. And if I break that down, and that's why I chose this one, it's a little bit easier to work with because they could get very complicated. So the sum of cubes, if you factor that out, remember it's a cubed plus b cubed, and we do same, opposite, always positive. We put in the signs first. Then we'll have ab, and then a squared minus ab plus b squared. So this factors out to x squared plus 9 times the quantity x to the fourth minus 9x squared plus 81. So the first part, x squared plus 9, we solve that very simply. Just subtract 9 to both sides, take the square root, and I have x is equal to plus or minus 3i. There are my two solutions, plus or minus 3i. Now the next part, this looks like a quadratic, but it's not quite because this is a fourth degree polynomial. So in order to use the quadratic formula, which I need to do to solve this, so I can't complete the square without, or I can't complete the square or use the quadratic formula because it's not a perfect square. What I need to do is use a substitution. So I'm going to let a equal x squared. So that's a squared minus 9a plus 81 is equal to 0. So now I can use the quadratic formula, and I would set this problem up. And then I would go through and solve it just like a quadratic equation from here. So a is going to be 9 plus or minus the square root of 81 minus 4 times 81 is 324 all over 2. So I have 9 plus or minus the square root of a negative 243 over 2. Okay, 243 is 81 times 3. And 81 is 9 times 9. So I have a pair of 9s. So I'm going to go ahead and pull out a 9. I have 9. I'm going to change this to 9 halves plus or minus 9 square root 3 over 2i because it is an imaginary. So now, since I know that a is actually equal to x squared, then x squared is 9 halves plus or minus 9 square root of 3 over 2i. So to solve this, I need to take the square root of both sides. So what I have is x is equal to plus or minus the square root of 9 halves plus or minus 9 square root 3 over 2i. Now, this gives me two solutions. This also will give two solutions. Because what's going to happen is I'm going to get a positive square root 9 halves plus or minus 9 square root 3 over 2i, and a negative square root 9 halves plus or minus 9 square root 3 over 2i. And then I have to use a positive and negative value here and a positive and negative value here. So that's 4 answers total. So I've got 4 solutions here and 2 solutions here. That's a total of 6. Okay. So you can see there's a lot of work here to find the 6th root of negative 729, and that's a real number. If we have a complex number where we're looking at a plus bi, then it's much more complicated. So there's got to be an easier way to get this done. So we have a formula here to finding the nth root of a complex number. For every positive integer n, the complex number z is equal to r cosine theta plus I sine theta has exactly n distinct roots. So that is exactly what happened right now for that problem we did. We took the 6th root and we had 6 distinct roots. Okay, so our formula is we're taking the nth root of z. We take the nth root of r, the modulus, times cosine theta plus 2 pi k over n plus I sine theta plus 2 pi k over n, where k is 0, 1, 2, 3, 4 to the n minus 1. So whatever our nth root is, if we did the problem we just went through, if we take 6th root, we're going to do that right now, the 6th root, we're going to start at 0 and end at 5. Okay, and that's going to give us 6 distinct roots. We'll start at 0 and end at 5. All right. So what I need to do first here, I want to find the 6th root of negative 729, is I need to put this negative 729 in trigonometric form. So that's the first step. Write in trig or polar form. All right, so first thing I need to do is find the modulus. So r is going to be the square root. And just in case you're not quite clear on this, my complex number is negative 729 plus 0i. There's no imaginary portion, so I'm just using that. So this is negative 729 squared plus 0 squared. So r is equal to the square root. Negative 729 squared is 729 squared. I just looked at this as negative 1 squared and 729 squared. So negative 1 squared is positive 1, and now I have 729 squared. And 0, I don't need to worry about that. So the modulus is 729. Okay. Now, where is the angle? What's the direction? Well, that's pretty simple. If I were to plot this complex number, if I were to put an argon diagram and plot negative 729, it would be way out here on the real number axis. That is pi. So my angle is pi. If I tried to do it the other way, algebraically, I would go tangent theta is equal to 0 over 729, and theta would be arctangent of 0. And what that would do is that would give you an answer of 0 degrees, and then you'd have to add 180 degrees, and that would give you pi, because it's in between quadrants 2 and 3. It's on this side. All right. So my complex number is 729 plus cosine pi times cosine pi plus I sine pi. That is my complex number in polar form. So now what we need to do is we need to find the sixth root of 729 times cosine pi plus I sine pi. Okay. Now this is where there's a lot of work involved. I've typed up part of it to make it easier for you to take notes. So make sure you printed this out so you can follow along. Because as you can see, there's a lot of work here. Okay. Sixth root of 729 cosine pi plus I sine pi. So we're going to take the sixth root of the modulus, sixth root of 729 here, and we're going to be multiplying our angle, which in this case, theta is pi. So I've put that in here, pi. That's what we're going to use for our angle. Whatever the angle of the complex number was, that's theta. And 2 pi k. K, we're going to start at 0. And because we're finding sixth root, we're going to go until we hit 5. So we start at 0 and go until we hit 5. So as you can see, I filled this formula out. Here's the sixth root of r. Here's our angle theta each time, plus 2 pi k. Now what's k? We're going to fill these values in. We're going to fill in 0, fill in 1, 2, 3, 4, and 5. That's your first step. Fill out these formulas. Sixth root, there should be 6 roots, 6 equations you have to work with. So here they are. Okay, next step is we're going to move over to another column here and we're going to simplify these. So 2 pi times 0 is 0, which leaves us with pi plus 0 over 6, or just pi over 6. The sixth root of 729 is 3. Okay, if I work that out on the calculator, (729) raised to the 1/6 power, that's sixth root, is 3. 3. Okay. So this is 3 times the cosine pi over 6 plus I sine pi over 6. 3 times the cosine of, this is 2 pi plus pi, which is 3 pi over 6. And 3 pi over 6 is pi over 2. So that's pi over 2 plus I sine pi over 2. When k equals 2, I have 3 times the cosine of 2 pi times 2 is 4 pi. 4 pi plus 5 is 5 pi. This is 5 pi over 6. 5 pi over 6 plus I sine 5 pi over 6. When k is 3, 2 times 3 is 6. 6 plus 1 is 7. This is 7 pi over 6. So 3 times the cosine of 7 pi over 6 plus I sine 7 pi over 6. K is 4. 2 times 4 is 8. 8 plus 1 is 9. That is 9 pi over 6. And I can reduce that. So this is 3 times 9 pi over 6 is 3 pi over 2. So cosine 3 pi over 2 plus I sine 3 pi over 2. And when k equals 5, the sixth root of 729 is 3. 2 times 5 is 10. 10 plus 1 is, this is 11 pi over 6. So cosine 11 pi over 6 plus I sine 11 pi over 6. Okay. Now we're about to get our solutions. We're going to get 6 solutions in standard form. What we need to do is we need to simplify these and we need to convert these. These are all in polar form now. We just need to convert them back to standard form. So the cosine of pi over 6 is square root of 3 over 2. And the sine of pi over 6 is a positive 1/2 I. So what I'm doing is I'm going to distribute the 3 to that. And I get 3 square root 3 over 2 plus 3/2 I. There's the first root. Next, the cosine of pi over 2 is 0. The sine of pi over 2 is 1 I. So we're going to multiply and distribute 3. So if I multiply that out, that's just 3i, or 0 plus 3i. 5 pi over 6. Cosine of 5 pi over 6 is negative square root of 3 over 2. The sine of 5 pi over 6 is positive 1/2 I. So now I'm going to distribute 3 to that, and I get negative 3 square root 3 over 2 plus 3/2 I. 7 pi over 6. Cosine is negative square root of 3 over 2. Sine is negative 1/2, so there's negative 1/2 I. And we're going to multiply 3 times that. Negative 3 square root 3 over 2 minus 3/2 I. And now the cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is a negative 1 I. So distribute the 3, and I have this time negative 3i. And finally, our last one, 11 pi over 6. The cosine of 11 pi over 6 is positive square root of 3 over 2. The sine of 11 pi over 6 is negative 1/2 I. So I'm going to multiply that by 3. 3 square root of 3 over 2 minus 3/2 I. These are the 6 roots of 729 plus cosine theta plus I sine theta. Those are my 6 roots. Now, you may be asked to graph these. So you may be asked to give a graphical representation of the solution. Now, you may not know this, but this is pretty simple. When you plot all these points, it's hard to do it by hand. But if you go to Desmos or something like that, let me show you what happens. Okay, so I'm going to share my screen with you real quick. I plotted these all in Desmos. So let me show you what happened. Here on the left side of the screen are all 6 solutions. Now, I can't write them as complex numbers because it won't plot them correctly. So what I did was I put them as coordinates. 3 square root of 3 over 2 plus 3 over 2i. I just plotted it as a coordinate because that's what I would do. I'd go right and then up. And then 3i was 0, 3. I just went straight up. Now, if you look at those points, what does that look like to you? I wrote a little equation here to help you see it. They're circles. That makes a perfect circle. Those solutions, all of them will give you a nice circle every single time. So what you would do to show the solutions, typically what you do is you would graph a circle that has a radius of, you can see over here, the radius is 3 units. Now, why is the radius 3? What do you think the radius happens to be? It's the modulus. The radius is the modulus. Whatever that happened to be, the 6th root of 729 was 3. So that's how big that radius is. Okay. See, if I do this here, you can see the angles. Pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, 11 pi over 6. So I converted that real quick to a circle, and you can see the angles. So it makes a nice, perfect circle, those solutions. When you graph this, if you wanted to show your solutions graphically, what I would do is I would set up an X and Y axis. I would graph the circle, make the radius, whatever the modulus happens to be, you're going to make the radius that long. And then you're just going to draw a little broken line from the origin to each of these points. You would draw a little broken line to each of those points, and that's how you graph your solution. Okay. All right, now let's go back to my paper here. So this is what we just looked at. You saw those points, they all lined up, they made a perfect circle. Now I wanted to show you something here. So what I did was I drew a little line segment. And like I said, if you were to actually graph these on your own as showing the solution graphically, these would be broken and your circle would be a nice solid circle, okay? What I want to show you here is this. The angles between each of these answers are equal. From pi over 6 to pi over 2, that's 30 degrees to 90. From 30 to 90 is 60 degrees. This is 90, that's 150. From 90 to 150 is another 60 degrees. 150 to 210, 60 degrees. 210 to 270, 60 degrees. 270 to 330, 60 degrees. And 330 degrees back to 30 degrees is 60 degrees. So what we're doing here, it's a rotation. When you take the nth root of a complex number, you're actually rotating. Now, how do you know how much to rotate? Well, pretty simple. We were taking the 6th root. So what you're going to do is you're going to take 6, right? 1, 2, 3, 4, 5, 6 angles here, 6 sections. So you're going to take 360 degrees, divide that by 6, and we get 60 degrees. So this will be the space between each solution. Okay. Why do you need to know that? How is that possibly going to help you? Here's how it's going to help you. Once you find the first angle, once you get the first one, in this case it was pi over 6, you don't need to go through this anymore. These steps now are obsolete. You don't need them anymore. All you have to do is add 60 degrees. Here we go. 60 degrees is pi over 3. Now that was pi over 6, so a common denominator would be multiplied by 2 over 2, and that's 2 pi over 6. Now here's pi over 6. I would add 2 pi over 6, and I would get 3 pi over 6. Add another 2 pi over 6, you get 5 pi over 6, 7 pi over 6, 9 pi over 6, 11 pi over 6. So you don't need to go through all this just one time. You've got to go through this one time. You must find the first angle, the initial angle. Okay, once that's done, take 360 degrees, divide it by whatever that nth root is, and add that angle every single time, and you'll fill these values out, and then you can simplify. Let's take a look at one more example. So here, I want the 5th root of 6 times the cosine 2 pi over 3 plus I sine 2 pi over 3. All right. So let's see what we're going to do. First of all, 5th root. So I'm going to take 360 degrees, divide that by 5. Try to get rid of that glare. 360 degrees divided by 5 is 72. So we're rotating by 72 degrees each time. All right, let's convert that to radians because I need to know what's going to happen. So converting it to radians, if I multiply this by pi over 180 degrees, let's see, I know, let's see, 72 pi over 180 degrees. I know 9 goes in there. 9 goes into 72 8 times. And 9 goes into 180 degrees 20 times. So that's 8 pi over 20. And then 4 goes in there. 2 pi over 5. So 72 degrees is 2 pi over 5. All right, let's get to work. So all of this, we don't need it. Don't need to do all that. Just need to know how many roots am I going to have. I'm going to have 5. So I know to stop after I have 5. I have to do this first one, k equals 0. All right. So what I'm looking at is 2 pi over 3 divided by 5. All right, so, and don't try to save paper and do it in your head because there are too many people that have messed up doing this. Most on some recent exams, you guys have messed up. So 2 pi over 3 divided by 5 is 2 pi over 3 times 1/5. I can tell you right now where the issues were coming in, half angle formulas. That's where the problems were coming in. So this is 2 pi over 15. So here is my initial angle, 2 pi over 15. All right. So I have the 5th root of 6. This is not going to come out to a nice number. It's going to be a decimal, so I'm going to leave that alone. Times cosine 2 pi over 15 plus I sine 2 pi over 15. And now 5th root of 6, 5th root of 6, 5th root of 6, 5th root of 6. We're going to have 5 solutions. All right. My denominator is 15, so I'm going to take that 2 pi over 5 and multiply it by 3 over 3. So I'm going to add 6 pi over 15 each time. So this is going to be the cosine of 2 pi over 15 plus 6 pi over 15 is 8 pi over 15 plus I sine 8 pi over 15. Cosine 8 pi over 15 plus 6 pi over 15, so 8 plus 6 is 14. That's 14 pi over 15 plus I sine 14 pi over 15. And just in case we want to see it again, if we add another 6 pi over 15, that's the cosine of 20 pi over 15. And we can reduce that if you want, or you can leave it alone. 20 pi over 15 plus I sine 20 pi over 15, because we're just going to feed this in our calculator anyway. Add another 6 pi over 15. And I have cosine 26 pi over 15 plus I sine 26 pi over 15. So we saved ourselves a bunch of work. We just found out what that angle of rotation was going to be, the angle of rotation, 72 degrees, and added it each time. So we have our 5 solutions. And now is calculator time, because there's no other way to get these solutions. So what I'm going to do here is I'm just going to type this in. So I have the 6th root of 5, the 5th root of 6, so 6 raised to the 1/5 power times the cosine. I didn't need that first parenthesis. Cosine of 2 pi over 15. So the cosine of the quantity 2 pi divided by 15. Okay. Now I did need that parenthesis there, because I don't want to take 2 multiplied times pi, the cosine of 2, then multiply that by pi, and I don't want to do that. So make sure you got parentheses. And I got to close this just because of that one I started on the outside. Let's see. 2, yeah. And that's 1.31. And then I've got to do the same thing. 6 raised to the 1/5, 5th root of 6, times the sine of the quantity 2 pi divided by 15. If you notice on my calculator when I'm doing this, I am in fact in radian mode. So that's why this is working, 2 pi over 15. So this is plus 0.58 I. And then you just go through and do the rest of this the same way. It's just hammered out in your calculator for now and get this out. Most likely when it's something in this manner, we're going to want your answer in polar form, trig form. We generally don't want this to be converted here unless we give exact solutions, and that involves radicals. If we can't get exact solutions, if these aren't angles we know, most likely we're going to be using this form as your solution. Okay, but pay attention to the instructions. You may want it in standard form as well. All right, this wraps up our study of some of these advanced topics in trigonometry. We'll move on next time to, well, we're going to cover some logarithms next. All right, until then, take care, and I'll see you later.